So I have to tell you, it was daylight savings time this weekend, as well, half the class knows. I woke up yesterday and I didn't even know it was daylight savings time. Until my wife said, "How come my cell phone says this time and my watch says this time?" And I'm like, "Oh, is it daylight savings time?" Anyway, doesn't that kill you every semester? All right. Anyway, let's talk about 5.2, which is solving. Well, I'm just going to abbreviate it. 3 equations, 3 unknowns. Okay? And maybe I should say these are linear, because it won't work that way the other way. Okay, so let's say we have an equation, x minus 2y minus z equals 1. Y plus 2z equals 3, and z equals 3. Okay, this is probably the easiest type of problem you'll see. So, how about Derek? Can you help me solve that?
Would you try and cancel out like a z or something through all of them?
Cancel the z. I would actually, you've already got one solved right there.
Oh, I see. So you just plug that in.
So we can plug that one into here, right?
Yeah.
And that becomes
Y plus, is that 2z?
2z.
So you'll.
So 2 times.
Oh, 2. Okay, 2.
Oh, it's supposed to be a 2. I put zz, didn't I? That's what I meant.
So yeah, then you put a 3 in.
Times 3
And
equals 3. 2 times 3 is?
6.
Then you're going to subtract.
So y equals 3.
Y equals -3.
And then you plug that one in the top.
Into the top one. Both of these into the top, right?
Oh.
So that gives me
So -3.
x. Well, we don't know what x is, right? X minus 2 times
-3.
-3 minus
3.
3 equals 1. So -2 times -3 is
+6.
+6 minus 3.
So it's +3.
So we're going to subtract 3 from both sides, and that's going to give us x equals -2. Okay? Now you could write this as an ordered triple, -2, -3, and 3 if you wanted to. Now just think about that. If we were to look at my graph here, if this is the x-axis and this is the y-axis, your z-axis would be sticking out of the board if we had a 3D board. Okay? And so you'd be at -2, -3, and then, well, if this was a x-axis, you'd be 3 units into the board, assuming that's plus. Okay? So anyway, let's go to another one. Okay, how about x minus 2y plus 3z equals 1, x plus 2y minus z equals 13, and 3x plus 2y minus 5z equals 3. Okay? All right, so now I'm going to erase this one. This is the easy one. This is what we call, by the way, back substitution. Okay? And this is something we're going to be doing later on, but more of your problems are going to look like this. Okay? So the idea here is pick one letter to eliminate with two equations. Step 2 is repeat with two different equations. Okay? And then step 3, repeat with another variable. Okay? So as we look at this problem here, Alyssa, which looks like the easiest letter to eliminate? The X's, the Y's, or the Z's?
I would say X.
You'd say X?
At least for the first two.
See, I would have said Y.
Oh, because they're all two.
They're all 2, right?
Yeah, that makes
These
sense.
columns are all here. They're all, the only difference here is positives and negatives.
Mhm.
So that's actually good for us, right?
Oh, yeah.
So we can take these first two equations here, and we can eliminate the y's very easily, right? Just by adding them.
Mm-hmm.
So x plus x equals
2X.
2x. Negative 2y plus 2y,
0.
0. 3z minus z
2Z.
plus 2z equals 1 plus 13,
14.
14. Now we need to repeat this, but we're going to use two different equations. So one of those equations we'll use again and one we won't. Okay, so which equations should I use if we label these as equations 1, 2, and 3? We used 1 and 2 last time. We can either use 1 and 3 or 2 and 3. Which would you prefer?
1 and 3.
1 and 3. So we're going to use these two equations here. Okay? So x plus 3x equals
4X.
4x. Negative 2y plus 2y,
0.
0. 3z minus 5z,
2. Negative 2Z.
negative 2z equals 1 plus 3 is 4. Okay? Now we're going to repeat with another variable. Which variable looks easier to eliminate?
Z.
The z's, definitely, right? Because those are going to go away. 2x and 4x is
6X.
6x equals
18.
18.
Divided by 6.
Divided by 6,
Equals
x equals
3.
3. Okay, so now we get to do our back substitution. So we can plug it into either of these two equations. Which one would you prefer?
Doesn't matter.
Doesn't matter.
Okay, we'll do the 2X one.
2x equation.
Yeah.
So 2 times 3 plus 2z equals 14. 2 times 3 is 6. We're going to subtract 6 from both sides. 2z equals
8.
8. Divide by
2.
2. Z equals 4. Now we'll take both of these, we plug it into any of those top equations. Which one would you like to plug it into?
Let's do number 2.
Equation number 2?
Yeah.
Okay, so x, which is 3, plus 2y equals, x plus 2y minus z minus 4 equals 13. So 3 minus 4?
Negative 1.
Negative 1, so we're going to add 1 to both sides. 2y equals 14.
Divided by 2.
Divided by 2.
Equals
Y
7.
equals 7. Okay? So if we were to write this as an ordered triple, it would be
3, 7, 4.
okay? All right, piece of cake. Okay, we got to get really good at this because the rest of this chapter depends on us. Okay? All right, so how about, let's do another problem just to make sure we know what we're doing. Can I erase my directions here? You guys all remember that? Okay. All right, let's go with x plus 2y minus 2z equals 1. 2x plus 2y minus 2z equals 6. 3x plus 4y minus 3z equals 5. Let's see, whose turn is it now? Must be Tyler's turn. What do you think?
Ready.
Okay, so which variable looks easiest to eliminate? The x's, the y's, or the z's?
Looks like the y's to me.
The y's, we could take equation 1 and we can subtract equation 2, right?
Yes.
Okay, so we're going to use these first two. So x minus 2x,
Negative x.
negative x. 2y minus 2y,
0.
0. Negative 2z minus negative 2z.
Negative 4z.
So, no, a minus, that's a 0,
Oh, wait, no. Yeah.
right? So both of those, so these two eliminate each other, right? If we subtract them. 1 minus 6 equals
Oh, negative 5.
negative 5. So we multiply by negative 1, now we got positive 5. Okay? Well, that worked out surprisingly well. I guess what we could do in this case is, I guess my rules don't apply this time, because now I can just plug this in, right?
Right.
So in fact, I'm going to plug it in the bottom two equations. So that's going to give me 2 times 5 plus 2y minus 2z equals 6. And 3 times 5 plus 4y minus 3z equals 5. Okay? So I could subtract 10 here, right? And I could subtract 15. This gives me 2y minus 2z equals negative 4, and 4y minus 3z equals negative 10. Right? Now, which looks easiest to eliminate?
From those two?
From those two.
Yeah. I would say the y's still.
The y's, you could multiply this top equation by negative 2, right?
Yeah.
And then it would eliminate the y's, okay? That would give me negative 4y plus 4z equals positive 8. Okay? I think I must have wrote this problem down wrong or something. All right, anyway, so the y's eliminate. I'm going to get z equals negative 2. This is really surprising to me. All right, and then what?
Let's see, plug the z into. You could probably just do any of the equations, right?
And you could do either these two or you could do any of those up there.
Okay, then let's just go with the top one.
The top one?
Yeah.
This top one and that top one?
Top one with 3.
This in here?
Yeah.
Okay, so that gives me 5 plus 2 times y, we don't have that, minus 2 times negative 2 equals 1, okay? So negative 2 times negative 2 is?
4.
4 plus 5?
Just writing down all the sections.
Yeah.
That'd be 9.
9, so we're going to subtract 9 from both sides. 2y equals negative 8.
Divided by 2.
Divided by 2.
4.
Y equals negative 4. Okay. Oh, that's funny. Yeah, I wrote the problem down wrong. All right, let's do another one. Let me pick another color. How about x minus y plus 5z equals negative 2, 2x plus y plus 4z equals 2, 2x plus 4y minus 2z equals 8. I'm going to make sure I put that right here. All right. So let's go with Mauricio. Which letter looks easiest to eliminate, the x, the y's, or the z's?
X.
X, okay. How do you want to eliminate the x?
You can pick equation 2 and 3 and
So 1, 2, and 3, and we're going to subtract 2 minus 3.
yes.
Okay, so we're going to take these two, we're going to subtract them. So 2x minus 2x is 0. Y minus 4y,
Negative 3y.
negative 3y. 4z minus negative 2z is
6z.
plus 6z equals 2 minus 8,
Negative 6.
negative 6. Okay, so since we eliminated the x's, we got to do it again. And we're going to do it with how?
3 and 1.
3 and 1. And so with 3 and 1, what are we going to do?
You gotta multiply equation 1 by negative 2.
And negative 2. Okay, so I'm going to rewrite this down here to make it a little bit easier.
Okay.
So this becomes negative 2x plus 2y minus 10z equals 4, right? And so we're going to take these two equations here,
Yes.
and the x's are going to eliminate, okay?
Then it's gonna be plus 6.
6y
12z.
minus
Negative
12z equals
12.
12. Okay? So now, what are we going to do? We're going to eliminate the z's or the y's?
Z's.
The z's, how do we do that?
You gotta multiply the first equation by negative 2.
Well, the first equation by negative 2. So negative 2 times negative 3,
It'll be 6y.
6y. Negative 2, no, we want to do it by positive 2, don't
Oh,
we?
yes.
Positive 2, so that becomes a negative 6y. Okay?
My bad.
So 2 times 6,
12z.
12z, and it's positive. And 2 times negative 6,
Negative 12.
negative 12. Okay, so those eliminate, but those also eliminate. And those eliminate. So I get 0 equals 0. Is that a true statement?
Yes.
Okay. Now, if this happens, here's what I would like you to say. And the book's going to give you something else, but I'm just going to say it's a dependent system. Okay? Basically, when you look at these two equations here, you got the same things twice. These are basically the same equations, right? Twice. Okay? So, one is just a multiple of the other. So you actually have an infinite number of solutions. There's not enough information for a single solution, okay? So in this case, this is what we would get. Now, if I had gotten 0 equals 7, what would we do in that situation? What'd you say?
Like it's not a real solution.
Yeah, so the answer, if you get something like this, is going to be inconsistent. Okay? So make sure you understand the difference between a dependent situation and an inconsistent situation. Let me see. This last one is funny because I wrote the problem down wrong. It was supposed to be inconsistent, but because I wrote it down wrong, we actually got a good answer, which is really surprising. So let me do this one again. And this time, I'm going to write the problem down right. I shouldn't give away the answer before I do it, but it's too late, I already did. All right, so what if x plus 2y minus 2z equals 1, 2x plus 2y, this is supposed to be a minus z equals 6, and this is supposed to be 3x plus 4y minus 3z equals 5, okay? So I'm going to erase this. All right. So, Reagan, let's go back to this problem. What looks like the best letter to eliminate? The x's, the y's, or the z's?
The y.
The y's, once again. How are you going to eliminate the y's?
We can take the first and second.
Okay, we're going to take the first equation, we're going to
Yes.
subtract the second equation.
Yes.
So x minus 2x,
Would be negative x.
negative x. 2y minus 2y,
Would be 0y. So
negative 2z minus negative z.
would be 3z.
No, it would be negative z.
Yeah.
Okay? 1 minus 6,
Oh, negative 5.
negative 5. Okay? So we did use those first two equations. Now we've got to eliminate the y's again using two different equations.
We could do 2 and 3. We would just have to multiply equation 2
Okay,
by
so
2.
we're going to multiply this by 2 or negative 2?
Negative 2.
Negative 2, and so we're going to, well, here, tell you what, rather than do that, I'm going to rewrite this down here. So this becomes negative 4x minus 4y
Plus 2z.
plus 2z equals
Negative 12.
negative 12. Okay? So now we're going to add these two equations together. The y's are going to go away. I'm going to be left with
Negative x.
negative x.
Is that a 2?
That's supposed to be a 2.
Okay, sorry. Minus z.
Minus z. 2, let's see, minus 2z. Yeah, it is minus z, that's correct. Equals
Negative 7.
5 minus 12 and negative
minus.
7. No, we're adding them. 5 minus 12 and negative 7, right. Okay? So now if I change the signs here, plus, 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 right? Now I've eliminated the x's, eliminated the z's, and I get 0 equals 2. And when is that true?
Never.
When I owe you money. Okay? So this would be called what? Inconsistent. Okay? Question?
For the last part of the problem there, when we multiplied equation 2 and 3, you used the negative 2. What would happen if you used a positive 2?
And all your signs would be messed up.
Oh, okay. And then why's that?
Why is that?
Uh-huh.
So, you wanted to multiply this by a positive 2?
Yeah, in this case, like, if you did that,
Okay, so you get 4x plus 4y minus 2z equals 12, right?
Yep.
And we're trying to, and then we're taking 3x plus 4y minus 3z equals 5. We're trying to eliminate the y's. I guess you can do that. I always prefer to add rather than subtract.
Okay.
But you could take this one and subtract this one, and that would be okay. But I prefer to add rather than subtract. So I guess technically that's not wrong, but it's more of a preference. Okay? And then theoretically you should get the same thing. Okay? All right, let's do one more. No, it's not. Oh, you know what? Let's start on 5.3, which is partial fractions. Because this is probably going to take more time than I have tomorrow, and we'll do the easy stuff today. Where's my eraser? All right. This is 5.3 partial fractions. Okay, now, before I do anything hard, here's what I'd like to do. If you did 1/2 plus 1/3, you could figure out what that equals, right, Landon?
Yes.
Okay, how would you do that?
Find a common denominator.
You get a common denominator of
6
6, and so you'd multiply this by what?
by 3.
3 over 3. You'd multiply this by
2 over 2.
2 over 2. And so you would get 3 times 2 is 6. So 3 times 1 is
3.
3. 1 times 2.
2.
So you get 5/6. Correct? Okay. Now the question is, if I gave you this answer 5/6, could you turn that into 1/3 plus 1/2? Okay? Now that's kind of a trivial problem, it's not that big of a deal, but what we're going to do is we're going to do partial fractions, and that's basically the idea. I'm going to give you this, and I want you to find 2 other fractions like this and this to do that. Now, let me just tell you guys, this is a favorite section for the calculus teachers. They love it when you guys know how to do partial fractions, because it makes your math a little easier. And basically, here's what we're going to do. I'm going to give you 4 cases. Case 1 is distinct linear factors. Okay? We're actually going to do 4 cases. And I'm going to show these to you one at a time so that you can, we'll save the rest for tomorrow, okay? All right, so case 1, distinct linear factors. And maybe I should put, well, I'll just leave it that way. Okay, let's say that I want you to find partial fractions for 5x plus 7 over x cubed minus plus 2x squared minus x minus 2. Okay? Now, can you factor that, Sam? If we did say factor by grouping, what would you factor out of here?
I will factor x squared,
X squared, you'd be left with,
x plus 2,
and then you could factor out a -1 and you'd be left with
x plus
6 plus 2, okay? Can you combine those?
yeah,
Okay, so this would be x squared minus 1 times x plus 2. Can you factor that?
yeah,
That would be
x plus 1
x minus 1,
and this
x plus
minus
2. Okay, so you see that each of these 3 factors here, what's the highest degree on them?
3.
highest degree is 1. These are all linear factors, correct? Okay. So this is case number 1. We have distinct linear factors. So if I go back to this original thing here, what I'm going to do is I'm going to break this up into 3 fractions. Okay? X plus 1, x minus 1, and x plus 2. Okay? So we're going to break this up into what the original factors were. Okay? Now, I'm going to put an A here, a B here, and a C here. Okay? This is case number 1. Okay? Now, this is the entire, so if you were to combine all 3 of these, you would end up with x squared plus 2x minus x minus 2, correct? Now, in order to get this common denominator, what would I multiply x plus 1 by to get this? I've already got an x plus 1, right? So I need to multiply by these 2. So I need to multiply this by x minus 1 and x plus 2. X minus 1, x plus 2, correct? You see that? What do I multiply this by to get this?
X plus 1.
X plus 1 and x plus 2. So this is x plus 1, x minus 2. X plus 1, x minus 2. Okay? What do I multiply this by to get this?
X plus 1.
X plus 1, x minus 1, right? Which is actually x squared minus 1. I'll just save myself a tiny bit of work there. Correct? Okay? Now, what we're going to do is we're going to just FOIL all this out. I'm in a hurry because I know we're out of time. This becomes A times x squared plus x minus 2. This becomes plus B times x squared plus x, no, minus x minus 2. And this becomes plus cx squared minus c. Okay? Now, I'm going to ignore the denominator because I don't need it anymore. Okay? Now, this becomes ax squared plus ax minus 2a plus bx squared minus bx minus 2b plus cx squared minus c. Okay? Now, here's where the last section comes in handy. Okay? So basically, we have to turn whatever this was into this. Do I have an x squared term here? No. So my x squared term, okay, so I'm going to come up with 3 equations and 3 unknowns. My x squared terms, I've got an a plus b plus c. There's no x squared term here, correct? So that's going to equal 0x squared. Okay, so I've just taken out all 3 of those. Now I'm going to take my x terms. This is going to be a minus b equals, in this case, 5. And then finally, I'm going to take my number term, which is going to be negative 2a minus 2b minus c. What does that have to equal for my number term? 7. Okay? All right, now I've got 3 equations, 3 unknowns. Y'all just showed me you know how to solve that. And basically, because we're out of time, I'm not going to solve it, but the answers should be, so the a term is going to go here, the b term is going to go here, and the c term is going to go here. If you solve this, you should get a equals 2, so you're going to get 2 over x minus 1, plus b, which is negative 1 over x plus 1, plus c, which is negative 1 over x plus 2. Okay? So as far as the quiz tomorrow, all of 5.2 number 3 and number 13 and 14 and 16. 3, 13, 14, and 16. I know you can do those off the top of my head. That'll be the quiz tomorrow, okay? So see y'all tomorrow. Yeah.